Okay, question 7, really common questions now about radioactivity. So this question is about radioactivity and its uses. Which of these radiations does not have a charge? Alpha's positive, beta minus, it tells you it's got a charge. Beta plus tells you it's got a charge. So the one is gamma, that is light from when the nucleus reshuffles itself. Which of these radiations is used in smoke detectors? So we know we'll have a little source of radiation. We have a detector, a couple of centimeters. And what this does is when there's no smoke, the air gets ionized and therefore there is a current. If the smoke gets in the way, there's less ionization and this triggers the smoke alarm. But the crucial part is you know that it is an alpha source. We've got a small gap. We want something that is a poor penetrator. So it's going to be alpha. Now we've got a common question and we can see here we've got the rollers and measuring thickness, and you know we need a beta source. The crucial part for that is because some is absorbed and some is transmitted, and because of that feature, that enables us to measure the thickness. So name the type of radiation to check the thickness of the paper. Beta radiation, you can use beta plus or beta minus. Give the name of one device which could detect this type of radiation, and that's your Geiger-Müller tube or your Geiger counter. So your Geiger-Müller tube or your Geiger counter. Question 7, when the paper is the correct thickness, the count is 4,000. So let's just picture that. So when it's doing that, here is my source. I'll flip the detector over this time. So I'm reading 4,000 there. We know that if the value went up, the paper would be thinner. If the paper went down, so if it went up, we've got thinner paper. If it went down, we've got thicker. And it's gone down because less can pass through. So the count rate increases when the paper gets thinner. Give one reason for that. More can be transmitted through. So more radiation can pass through or transmit through the paper. Whoops. The rollers need to be adjusted if the count rate increases by 5%. Calculate the maximum count rate that could be allowed. So we've just got to work out what's 5% of 4,000 and then add it on. So 5% of that is 200 and then add it on 4,200. On to the next one. Big common 6 marker now. We've got radioactive tracers. And we know we'll have a protein that can attach to a tumour. We'll put a piece of radiation on it, usually gamma radiation, and then we'll inject it. So that's tracers. But we also know we've got the gamma knife. We could also talk about alpha and beta implants. So really, there's a lot that you can pick here. I'm just going to go, because it's for your revision to go through, I'm just going to go through a range of answers here. So a gamma radioactive source is attached to a protein that can attach to tumours. This is injected into the patient. The source concentrates in the humour and gamma transmits through the body. We can detect it and turn it into a 3D picture. Okay, so that's that. Oh, apologies. Next one, we can then talk about the gamma knife or radiotherapy. A wide, low intensity beam is moved around the tumour, moved around the patient, focusing on the tumour. This kills some healthy cells, but all of the cancerous ones. So to turn this into daft little pictures, get a protein, attach some radiation, inject it. Here's the tumour. Now this is highly radioactive. That can pass through the body. We then detect it. There's an eye, and we turn that through a computer into an image of the tumour. That's that one. And the next one is, imagine that's a patient's head and there's the tumour. We're going to blast it with gamma, and let's say it kills 1% of the cells. And this is why it causes some side effects. And then we blast it there and the tumour's had an additional dose, and we get this idea that it moves around the patient. And that is a nice 6 marker. Please make sure you learn that.